Day 2 of radical operations. Today we're going to look at adding, subtracting, and some more multiplication and division. Now, just like with variables, when we add things they must look the same, which means in this case your square roots must have the same number inside of the radical. The first problem we have is 5 square roots of 3 plus square root of 27. Unfortunately, these are not the same square roots because 3 is not the same as 27. In order to do this problem, we will first have to simplify anything that can simplify. The problem on the right, square root of 27, can actually be broken down into the square root of 9 times the square root of 3. Square root of 9 is just 3, so we're looking at 3 square roots of 3. We have 5 square roots of 3. And now they have the exact same radicals, so we can go ahead and combine them. 5 plus 3 is 8, so it's 8 square roots of 3. If you need to think about it, it's just like saying 5x's plus 3x's give you 8x's. Let's look at another one. Square root of 50 minus square root of 48 plus the square root of 8. None of them look the same. I know 50 is the square root of 25 times the square root of 2. I know the largest perfect square that goes into 48 is 16, so 16 times 3. And I know the largest perfect square that goes into 8 is 4, so square root of 4 times the square root of 2. Square root of 25 is 5, so this ends up being 5 square roots of 2 minus square root of 16 is 4, so 4 square roots of 3 plus square root of 4 is 2, so 2 square roots of 2. Now all I have to do is look at the ones that look the same, which means, for example, we have square root of 2 and square root of 2. We can combine these. 5 square roots of 2 plus 2 square roots of 2 is 7 square roots of 2 minus 4 square roots of 3. Notice I just carry down the sign. Now some books require that you put the biggest square root first. I'm not going to be that picky. Just make sure you have both pieces. Now we can't combine 2 and 3 because the square root of 2 is a very different decimal answer than the square root of 3. The next two we're going to try to distribute using the same idea. Distributing as simple as what we would normally distribute. 8 times 3. Well, 8 times 3 is 24. Now we're going to do 8 times, notice it's minus, so it's a negative, negative 5 square roots of 6. We can multiply integers together and then multiply radicals. Or I sometimes say outsides times outsides, insides times insides, or you could say whole times whole, part times part. So my whole numbers are 8 times negative 5, which is negative 40. And then I have a square root of 6 that tags along. Square root of 6 doesn't simplify, so that is my answer. Now when we list these, we do always put the real part first, which means we put the whole numbers. Anything with square roots always come second because they're called complex numbers. Let's try another one. We're going to take 2 square roots of 5 times 4 square roots of 5. 2 square root of 5 times 4 square root of 5. We're going to multiply the outside numbers. 2 times 4 is 8. We're going to multiply the inside numbers. 5 times 2 is 10. Now we repeat this process with the second problem. 2 square root of 5 times negative 9. 2 square root of 5 times negative 9. Multiply my whole numbers, or my integers in this case. 2 times negative 9 is negative 18 square root of 5. Now 10 has no perfect squares that go into it, and 5 doesn't either. Square root of 10 is very different than the square root of 5, so we leave them be. Let's take it just one step further. Foiling. To FOIL, or to distribute many times, we use the exact same process as we did before. First times first, so 5 times 7 is 35. Now we're going to multiply the outsides. 5 times the 4 square root of 3. We have the 35. 5 times 4 is 20, so it's 20 square roots of 3. Inside times inside. So negative square root of 3 times 7. Well, 7's on the outside, and there's a negative on the outside, so it becomes negative 7 square roots of 3. Now, if there's no sign, then the sign is positive. And last but not least, we'll take the negative square root of 3 times the positive 4 square roots of 3. So negative square root of 3 times positive 4 square roots of 3. Well, negative times 4 is negative 4. Square root of 3 times square root of 3 is square root of 9, so we have negative 4 square roots of 9. We simplify anything we can. Well, there's an easy part over here. Square root of 9 is just 3, so that's really just 4 times 3, which is 12. So I have 35 minus basically 12, which is 23. Now I can combine anything else that looks the same. I have 20 square roots of 3 minus 7 square roots of 3, which is 13 square roots of 3. I look at my math problem and see if I have any other square roots, which I don't, so I'm done. One more multiplication. We're going to FOIL. So I'm going to do the square root of 8 times the square root of 8, which is the square root of 64, which is just 8. Outsides. Square root of 8 times the square root of 5 is negative square root of 40. Insides. Positive square root of 5 times positive square root of 8 is positive square root of 40. And then last but not least, last times last. Positive square root of 5 times negative square root of 5 is negative square root of 25. Well, I don't even have to simplify the middle part. If I have the exact same thing with two different signs, that portion is going to be 0, so that goes away. Minus square root of 5, or excuse me, square root of 25 is just 5. So 8 minus 5 is 3. I'll get it out there. So all that work for a nice pretty answer of 3. So hopefully this will help you with adding and multiplying square roots.